is Chapter 7 review, and we're going to do some selective problems from the chapter review, page 326, 327, for our review for our test. So we're going to do 2A and 2C first. And so let's take a look at these and see if we can figure them out. It says find each real cube root. If no real root exists, state so. All right, so question 2, part A, says the cube root of negative 64. What that's really asking is, what number times itself 3 times gives you negative 64? Now, can you multiply the same number 3 times and get a negative number? Yes, you can. A negative times a negative is a positive, and a positive times a negative is a negative. You can't have real roots if you have an even index and you got a negative radicand, but in this case you can. Now, you probably should know this one by now. What number times itself 3 times gives you 64? 4. So in this case, the number negative 4 times negative 4 times negative 4 is negative 64. So that one's just simply negative 4. Moving on to part C, it says the cube root of 216. So what number times itself 3 times gives you 216? And you should know this one by now, and it is 6. 6 times 6 times 6 is 216. All right, you probably should know your square roots and cube roots up to at least 10, perhaps 12. All right, so this is questions 2A and 2C. Moving on to question number 4, we're told to simplify and assume our variables represent positive real numbers. All right, so if we look at number 4, let's split it up into different parts. We've got the square root of 121 a squared b to the 4th. Well, let's just think about what's the square root of 121. Well, we know that. All right, and just the positive value is 11. Now, what is the square root of a squared? Well, we've been trying to teach that if this exponent right there is equal to or larger than your index, and the index is right there, in this case it's a square, a 2, all right, then you can simplify by dividing. 2 divided by 2 is 1, so it's a to the 1st, and there's no remainder there, 2 divided by 2, so there's nothing left under the radical. And then with your other part, you say, well, 4 divided by 2 is 2, so this simplifies to just being b squared. So the answer here is 11ab squared. Now, number 6, same type of problem, except this time we got a 4th root. The 4th root of 96 is 96 times r to the 5th. Now, there is no 4th root of 96. 2 to the 4th is 16, 3 to the 4th is 81, 4 to the 4th is way bigger than 96. So there's not a perfect 4th root. So we got to think, okay, is there a perfect 4th root that's a factor of that? All right, what's the first perfect 4th root? 16, right? Because 2 to the 4th is 16. So the first perfect 4th root is the 4th root of 16. That's 2. Now, if you take 96 and divide it by 16, guess what you get? You get a whole number. You get 6. 6 times 16 is 96. That means this right here is really 2 times the 4th root of 6. 2 times the 4th root of 6. I simplified over there on the side. Now, with the variable, you have r to the 5th. That exponent is greater than or of equal value to the index. So you say, all right, well, this is 5 divided by 4. And how many times will 4 go into 5? Once, with how many left over? Yeah, with 1 remainder. So that means 1r can be simplified out, and you have a remainder of 1, so 1r is still underneath the radical. So this is 2r times the 4th root of 6r. Moving on to question number 10, it says convert each radical to exponential form. So I'm not trying to simplify here. The only thing I'm trying to do is convert it to exponential form with exponents. So what's the index to this particular problem? Well, it's the square root. So the index is a 2. So this is simply 7, and it's to the 1/2 power. And it's x to the 1/2 power and it's y to the 5/2 power. So the only thing I was asked to do on question number 10 is change from radical to exponential. Now on number 12, it's vice versa. That is opposite. I'm going from exponential to radical. Now, if I'm going from exponential to radical, what has to be common? Yeah, the denominator. And right now I don't have a common denominator. I can't have a third root and a sixth root at the same time. I want to put them together. So I need a common denominator. So what's going to be the common denominator between 3 and 6? 6. So this one needs to change. So 3 times 2 is 6. So 4 times 2 is 8. So it's the same thing as 2 to the 8/6. And this one already has a 6th, 1/6. All right. So this in radical form is the 6th root, because the denominator is your index, of 2 to the 8th, a to the 1st. Now, let's simplify that, because we're told that if the exponent is larger than the index, larger than or of equal value than the index, we need to simplify it. So, what is 8 divided by 6? 1, with how many left over? 2 left over. So, it's 2 squared, and I'm going to go ahead and figure that out, because I know what 2 squared is. 2 squared is 4, and this a to the 1st will not simplify. So, it's 2 times the 6th root of 4a. Moving on to question number 14, we have 8 to the 1/3, and we're told to evaluate. Now, we don't normally evaluate when we have fractional exponents. What we normally do is we normally evaluate when we see radicals. So we probably want to convert from exponential form to radical form. So 8 to the 1/3 is the same thing as the cube root, that denominator is the index, of 8 to the 1st. Now, we know what this is, or at least we should. What number times itself 3 times gives you 8? It's 2, right? So 8 to the 1/3 is 2. Now, if you look at number 16, same type of problem to evaluate. We probably want to put it in radical form. So the index is 2, so we have a square root, and this is in parentheses. So 144, all right, to the 1st power. Now, there's not a real number that gives us this, but we can figure out what it is. All right, the square root of 144 is 12, and the square root of -1 is I. Remember, if you have an even index, you can't do radicands if they're negative unless you use complex numbers. All right, so just 12i, and we're just dealing with positive roots here. Moving on to question number 20, we're told to simplify, and it says assume variables represent positive real numbers. So we're not dealing with imaginary numbers, at least if the variables. Now it says nothing about constants. All right, the variables. So in question number 20, we have 3a squared b cubed all to the 1/3. Now you could use your power of property, or power of property of exponents, power property, and say, well, this is 3 to the 1/3, a to the 2/3, and b to the 3/3, which is just 1. That would really help us to simplify. What I want to do is probably convert to radical form. All right, that's what it is with exponents, but I really probably just want to say, well, this is everything to the cube root. Cube root of 3a squared b to the 3rd. Now, what's the cube root of 3? What number times itself 3 times gives you 3? We don't know without using a calculator, and there's not a perfect cube root. Because what is the first perfect cube root? 8. Right? So 8 can't be a factor of 3 since it's larger than 3. So we can't do anything with that. The a squared, that exponent is smaller than the index, so you can't simplify that. But you can simplify the b, because the exponent is of the same value as your index. So 3 divided by 3 is 1. So it's b to the 1st, and then the rest of it just stays under this radical 3a squared. So b times the cube root of 3a squared. Moving on to question number 22, we don't have any variables here, so we can use complex numbers. We have 5 square root of negative 27 minus 4 square root of negative 75. I don't know what the square root of negative 27 is. All right, I know it's an imaginary number, and there's not a perfect square root of 27, but there is a perfect square root that's a factor of 27. What's a perfect square root that's a factor of 27? Yeah, this is the same thing as the square root of 9 times the square root of 3 times the square root of negative 1. All right? Now, let's write that out then. What is the square root of 9? 3. Square root of 3? Don't know. It's just square root of 3. Square root of negative 1? I. Now, let's multiply that. What's 5 times 3? 15 times I. We can work that. So that's 15I times the square root of 3. Now, let's see what the other part simplifies to. We got subtract, or minus, 4 square root of 75. Well, I don't know what the square root of negative 75 is, but what's a perfect square root that's a factor of 75? 25. Square root of 25 times 3. And then you got the square root of negative 1. So this is equal to minus 4, and the square root of 25 is 5 square root of 3 I. So 4 times 5 is 20, and 20 times I is just 20 I square root of 3. Now, do you have the same index with your radical? Yes. Do you have the same radicand? Yes, so you can combine these. Remember, that's the rule when you're subtracting radicals. You have to have the same index and radicand. So 15I minus 20I is negative 5I times the square root of 3. Moving on to question number 26, we have 2 to the 1/3 times 2 to the 3/4. And what we want to do is probably, since we have the same base, when you have the same base, properties of exponents say add the exponents. So let's just add them together, but the problem is we can't add those two fractions together because they don't have a common denominator. So what is my common denominator? It's 12. All right. So 3 times 4 is 12, so 1 times 4 is 4. And 4 times 3 is 12, so 3 times 3 is 9. And 4 plus 9 is 13 over 12. So this is really 2 to the 13 over 12 power. Now, we don't want to leave it in that form because it's an improper fraction, so let's change it to a radical. So this is really the 12th root of 2 to the 13th power. Now, because that exponent is larger than the index, then we can simplify that. What is 13 divided by 12? 1, with how many left over? So I got 2 to the first, and I still have a 12th root of 2. Now moving on to 28, you have the square root of 4z times this binomial. So you need to distribute, and square root of 4z times 1, well, anything times 1 is itself, so that's just the square root of 4z. And the square root of 4z times square root of 2z, you can multiply radicals if the index is the same, and they are. They're both square roots. So 4 times 2 is 8, and z times z is z squared. You add your exponents when you multiply variables. Now let's simplify that. What is the square root of 4? 2. So that is 2 square root of z. Now the square root of z won't simplify. What's the square root of 8? I don't know, but I know that there's a perfect square root that's a factor of 8. Right? The square root of 8 is really the square root of 4 times the square root of 2. And the square root of 4 is 2. Now, this z, though, I still got square root of 2. This z is raised to the second power. The index is 2, so 2 divided by 2 is 1, so it's a z simplifies out, so I got 2z squared root of 2. Now, can you add these two terms together? Well, you can only add radicals if the index is the same, which it is, and the radicands. And they're not. So somebody said this is the radicands. So these cannot. Moving on to question number 30, we have a binomial times a binomial, so you should automatically think, okay, I need to FOIL, first, outer, inner, last, multiply here. So x times 2x is 2x squared. X times negative square root of 5 is negative x square root of 5. And inside, square root of 5 times 2x is plus 2x square root of 5. And then square root of 5 times negative square root of 5 is negative square root of 25. Now the outer and the inner are going to combine here. So I'll get 2x squared. What is negative x square root of 5 plus 2x square root of 5? Just 1x square root of 5. So plus x square root of 5. And then what's the square root of 25? 5. So you got minus 5 on the end. All right, and so this is what those two binomials multiply to give you. Now number 32, when we're simplifying, we are told in Algebra 2 to rationalize the denominator. That means you can't have a radical in the denominator, a fraction. So I can't have square root of 18. So how do I remove a square root of 18? Well, let's multiply by the square root of 18. And the square root of 18 over 18, or over the square root of 18 is 1, so you can multiply by 1 and not change anything. And the square root of 18 times the square root of 18 is just 18. Now, square root of 3 times the square root of 18, you can multiply since the index is the same. That's the square root of 54. Now, I don't know what the square root of 54 is, but I know that the square root of 54 has a perfect square root that's a factor. What's a perfect square root that's a factor of 54? Yes, 9 and 6. And the square root of 9 is 3. So it's 3 square root of 6 over 18. And you can reduce the 3/18ths. 3 goes into 3 once. 3 goes into 18 6 times. So my simplified answer is the square root of 6 over 6. And you can't simplify because one's under a radical and one's not. So those won't simplify. So square root of 6 over 6. Moving on to question number 36, we got 6 divided by 3 to the 1/3 power. A couple of ways you can do this. Probably the easiest way is just to figure out what 3 to the 1/3 power is, if you're able to. And it is really just 6, and I'm going to write this as a fraction, divided by. Now, if I change that to a radical, what's that going to be? Cube root of 3, right? 3 to the 1/3 is cube root of 3. Now, how do I get rid of a cube root of 3? Well, I need to get the same number of exponents as I do index. I have one exponent, 3 to the first power, so I need to multiply this one by the cube root of 3 squared. Because 3 times 3 squared is 3 to the third, and the cube root of 3 to the third is just 3. So I need to do this same thing to the top. And what is 3 squared? 9. So it's 6 cube root of 9. Now I can reduce my whole numbers here, integers. So 3 goes into both of these numbers. So my answer is 2 times the cube root of 9, and the cube root of 9 does not simplify. Moving on to question number 38, we're trying to solve here. Okay, we're changing gears and we're solving for x. If I want to solve for x, I need to get x by itself. Alright, so I need to, in this case, subtract the 5, take it to the right side, and I get the square root of x is equal to negative 1. Now, to get rid of a square root, we would square both sides, but I don't need to do that. Why not? Because unless I'm working with imaginary numbers, and I'm not here, then you cannot get a square root of a number to equal a negative number. Negative integer is not possible. So we would just say at this point it is the empty set. Moving on to question number 40, we have 25 to the x power is equal to 125. What we probably want to do is change these to the same base number. And 25 is 5 squared. And 125 is 5 cubed. Now this on the left side, power on a power, so that's really 5 to the 2x is equal to 5 cubed. Now if you have the same base number, that means your exponents, they must be equal to each other. So I'm going to say, well then 2x is equal to 3, so divide by 2, so x is equal to 3 over 2, or we could say 1.5. Right, 1.5. And then moving on to question number 42, you have the square root of x, and then you have minus 1, and the minus 1's not under the radical, is equal to the square root of x minus 7, which everything is under the radical. What I'm going to try to do is square both sides, and the reason I want to do that is because a square root gets rid of that square root. And so that helps me a little bit in the sense that I don't have that anymore, I just got x minus 7. But if you square one side, you got to square both sides, and you have to square both sides completely together, not just individual parts. So that right there I'm going to have to FOIL. So I'm going to have to come over here and multiply. And first, square root of x times the square root of x is x. Outside, negative square root of x. Inside, negative square root of x. Last, 1. And the outside and inside combine, so it leaves me with x minus 2 square root of x plus 1. Now let's get our x's on the same side, so let's move it to the left. So I'm going to move that x to the left side, and that cancels. And I need to move that constant, that negative 1, to this side. So I get negative 2 times the square root of x is equal to negative 8. Now I'm trying to get x by itself, so it's negative 2 times the square root of x, so let's divide by negative 2. And so, run out of room here, it gives me the square root of x is equal to positive 4. Now you can get square roots equal to positive numbers. So how do you get rid of a square root? Well, we'll have to square again. So square both sides. And the square root, or when you square a square root, they cancel. So you get x is equal to 16 in this case. Alright, that's Chapter 7 review. Thanks for watching.